Welcome to section 6.3, solve linear systems by adding or subtracting. So what we're going to actually be doing now is using a method called elimination, which will involve us adding or subtracting our two lines of equations together. And our goal when we do this is that we should eliminate one of the variables, hence calling it solving by elimination. So looking at this first equation, I'm going to suggest we add these two equations together. And the reason being is we have a positive 2x up top and a negative 2x on the bottom. And so if we add those together, they will cancel out, making a total of 0 x's. So if we add just straight down, 2x plus negative 2x will cancel out to be 0 x's, which means it won't actually end up mattering. 3y plus 5y will give us a total of 8y, and 11 plus 13 will get us to 24. Now I can divide both sides by 8, and we'll come up with a y equals 3. Now, what we have to do is we have to plug this 3 back in so we can solve for x. And again, you can choose either equation for this. I'll probably just do the top one. So 2x plus 3, and y is 3. Oops. So 3 times 3 equals 11. Well, 3 times 3, that's 9, plus 2x equals 11. So you can subtract 9 from both sides. So 2x is going to equal 2. You can now divide both sides by 2, and x is going to equal 1. And so now our answer is going to be the point 1, 3. Let's try that one again. This time, we have 4x plus 3y equals 2, 5x plus 3y equals negative 2. So I will actually subtract these because my goal will be to try to get our y's to cancel out since those have the same value. So 4x minus 5x will give us a negative 1x. 3y minus 3y will give us 0y. And 2 minus negative 2 will come out to be a positive 4. So in other words, negative 1x equals positive 4. So we can divide both sides by negative 1, and x equals negative 4. Now we can take that 4 and plug it back into an x up top. So you can have 4 times negative 4 plus 3y is equal to 2. Well, 4 times negative 4, that gives us a negative 16, plus 3y equals 2. And then add 16 to both sides, and we'll come out with a 3y equals 18. You can divide both sides by 3, and y is going to come out to equal 6. So our final answer in this case is a negative 4, 6. Let's try another one. This one, I'm going to end up adding these together again, because we have a minus 4y up top and a plus 4y on the bottom. So 8x plus negative 3x will get us to 5x. Our minus 4y plus positive 4y will cancel out. And negative 4 plus 14 will get us to a positive 10. Now we can divide both sides by 5 and find out that x has to equal 2. And again, you can go and plug this 2 into either x, but I'll just do it into the top equation again. So 8 times 2 minus 4y is equal to negative 4. And I'll probably make that minus 4y to a plus negative 4y. So now 8 times 2, that's 16, plus negative 4y is equal to negative 4. So we can subtract the 16 from both sides. So we'll get a negative 4y equals negative 20. Divide both sides by negative 4, and we come out with a y has to equal positive 5. So our answer in this case is 2, 5. The last one here. A kayaker travels 12 miles upstream against the current in 3 hours, and travels 12 miles downstream with the current in 2 hours. Find the speed of the current and the speed of the kayak in still water. So the basic premise for this one is just remembering that distance is equal to rate times time. So when we're going upstream, we go 12 miles, and that's going to equal our rate going upstream times our amount of time, so 3 hours. Well, that means when we're going upstream, we can divide both sides by 3. Our total speed is going to be 4 miles per hour. 4 mph. When we're going downstream, we go 12 miles in our rate times 2 hours. So we can divide both sides by 2, and we get that our rate is equal to 6 miles per hour. So that's the first part. The second part is trying to separate the speed of the current from the speed of the kayak if it wasn't in the current. So in other words, if you are going with the current, there is the speed of the kayak, which we'll call k, plus the speed of the current. They add together to give you your total speed when you're going with the current. So the speed of the kayak plus the speed of the current is going to give us our speed for when you go with the current, which was that higher speed. So that was that 6 miles per hour. Now, the speed of when you're going against the current, but you're making progress, that means the speed of the kayak is subtracting the speed of the current, and that will leave us with the speed when we're going into the current, which in this case is 4 miles per hour. Well, this is actually one that we can solve pretty easily. So what I'll do is I will just add these two equations together. So k plus k will give us a 2k. C plus negative c will cancel each other out, and 6 plus 4 gives us 10. Now we can divide both sides by 2, and we come out with the speed of the kayak is 5 miles per hour. Well, now we can go and plug that back in up here. So 5 plus some number gets us to 6. Well, that means the speed of the current has to be 1 mile per hour. So the speed of the kayak in still water is 5 miles per hour, and the speed of the current is 1 mile per hour. So that's all the more I've got for you for today. So good luck, and let me know if you have any questions.